We are solving now the questions regarding momentum topic for M1. Two particles A and B of masses 0.4 kg and 0.2 kg respectively are among the moving on the downward slope, which is a smooth plane. The plane is inclined at 30-degree angle to the horizontal and A is higher up the plane B. When the two particles collide, the speed of the particle A and B are 3 meters per second and 2 meters per second respectively. In the collision between the particles, the speed of the particle A is reduced to 2.5 meters per second. Find the speed of the particle B immediately after the collision. So in this question, they are asking about the two particles A and B, which is on a smooth surface of the plane, making an angle of 30-degree angle with the horizontal. The particle is at A, which is higher than the value of B, and its mass is 0.4 kg, and the mass of the B particle is 0.2 kg. It is moving with the initial speed of 3 meters per second, and this one is moving with the speed of 2 meters per second. After this speed is equal to 2.5 meters per second, and this V2 we are going to calculate for this part. So we know from the law of conservation of momentum, momentum before collision is equal to momentum after collision. So momentum formula is product of the mass and velocity. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, where m1 is 0.4 and u1 is 3 plus m2 is 0.2, u2 is 2 there, which is equal to m1 is 0.4 into v1 is there 2.5 plus m2, that is 0.2 into the speed of that object v2 is equal to v we are going to calculate. So if we do this calculation, this 1.2 plus 0.4 is equal to 1 plus 0.2v. So 1.6 is equal to 1 plus 0.2v. So it is equal to 0.6 is equal to 0.2v, or v is equal to 3 meters per second. This is the speed we have to calculate in this part 1 of this question there. Now, we are going to start the next part. After the collision, when B has moved 1.6 meter down the plane from the point of collision, it hits a barrier and returns back to the same line of the greatest slope. B hits the barrier zero point 0.4 seconds after the collision, and when it hits the barrier, its speed is reduced by 90%. The two particles collide again 0.44 seconds after their previous collision. After they have coalesced on this impact, after the collision, B has moved 1.6 meter down the plane from the point of collision. It hits the barrier and returns back to the same line of the greatest slope. B hits the barrier zero point 0.4 seconds after the collision, and when it hits the barrier, its speed is reduced by 90%. The two particles collide again 0.44 seconds after their previous collision, and they coalesce on impact. Show that the speed of the particle B immediately after it hits the barrier is 0.5 meters per second. Hence, find the speed of the combined particles immediately after the second collision between A and B there. This is particle A, this is particle B. Its mass is 0.4 kg, its mass is 0.2 kg, and there is barrier on this inclined plane which is making an angle of 30 degree. We know that B is coming downward and A is coming also downward. For this particle B there, this is the barrier. These are the components. It is R. This one is mg cos theta, and this one is mg sin theta. Because it is frictionless, a smooth surface, so friction is equal to 0. There is no extra force acting on the particle, so only this mg sin theta is used for the acceleration of that particle. We know driving force minus resistive force is equal to net force Ma. Driving force is mg sin theta minus frictional force is 0, the mass of that particle m into acceleration A there. So this m and this m cancel. So A is equal to g sin theta, and if you put the values into this equation, g is 10 into sine of 30, and that thing is equal to 10 into half, and that is equal to 5 meter per second square. Since this particle B has moved 1.6 meter before it hits the barrier, so we can calculate the total velocity of the particle B when it hits the barrier. So we know that v square minus u square is equal to 2s, or v square is equal to u square plus 2as. or v square is equal to the u speed of that particle. After this, it is going to be 3 meters per second. So this is 3 plus 2, acceleration is 5, and it has moved a distance of 1.6. So 9 plus 16, that is equal to 25, or v is equal to 5 meters per second is the speed of the particle b when it hits the barrier at a distance of 1.6 meter from that. Now, they said that after this b particle, when it hits the barrier, it bounces back. So, but its speed is reduced 90% of this previous. So, speed of the particle b after it bounces with the barrier is 90%, means what? 10% will be left of this 5. So that is equal to 0.5 meters per second is the speed of the particle of B after in contact with the barrier there when it returns back to that part there. So this is the part which we have to show in this, that it is having a speed of 0.5 meters per second. Now, in the last stage of this, this is your particle B there, and this is the particle A there. Now we are going to calculate the speed of the particle A, which is equal to u plus at. But we know that after the collision, the speed of the particle A there is 2.5 meters per second. It is before the collision of the second collision. So it is 2.5 plus acceleration we have calculated because it is coming downward. The same equation will be used, and that is equal to what? 5 into the time it has spent there is 0.44 second given in the question there. So velocity of particle A before the second collision is 4.7 meters per second. But for the particle B, as it moves upward, so when it is moving upward for this particle B, this so mg sin theta is downward, and there is no driving force. And if we use this equation, driving force minus resistive force is equal to net force. Driving force is 0, minus resistive force is mg sin theta is equal to ma. So A is equal to minus g sin theta, that is minus 10 into half, that is minus 5 meter per second square. Now you can have this further. For this particle B, before the second collision, this is the velocity of A before the second collision. So B before the second collision is, the speed is 0.5 meters per second, minus g is 5 into time there is, because the total time taken between these two is 0.44 seconds, and when they contacted each other, for that time is given there equal to 0.4 seconds. So total time will be 0.44 minus 0.4, or it should be equal to 0.5 minus 5 into 0.04, or it should be equal to 0.3 meters per second square. So when they coalesces with respect to each other, their masses are combined. So mass of A plus mass of B is equal to 0.4 plus 0.2, that is equal to 0.6 kg. And when they were combined together, let's say the combined speed of these two particles is supposed to be calculated there. Again, we will use the same equation of motions for these two, that momentum before collision for the second collision is equal to momentum after collision, but that is the second impact of this collision. So it should be equal to the mass of that particle A is there 0.4 into speed of that particle is 0.7 minus mass of that particle B is 0.2 and the speed it is moving 0.3. We are taking it minus because it's moving in the opposite directions towards that. It should be equal to 0.6 into V there. So after doing this calculation, the V value will be equal to 3.03 meters per second towards B there. So this is the final solution of this problem concerned with this question of momentum there.